Why does the powerless hydrofoil board fly like this with just a few steps? Don't you think it's amazing? Today, let's explore the principle behind it. This hydrofoil board is similar to a traditional surfboard, but at the bottom, there's a long tail-like hydrofoil, which is also what enables this board to fly. This hydrofoil is essentially like a small underwater airplane. It's designed similarly to a jet, utilizing the Bernoulli principle to generate lift. According to the Bernoulli principle, in fluid flow, the faster the flow, the lower the pressure, and the slower the flow, the higher the pressure. For the hydrofoil, if it moves underwater at a certain speed, the curved surface of the hydrofoil causes water to flow faster, reducing pressure, while the flatter surface slows the water flow, increasing pressure. This pressure difference between the two surfaces generates lift. The angle between the shape's chord line and the fluid flow direction is called the angle of attack. At a certain angle, the greater the angle of attack, the greater the lift. Under the influence of speed and angle of attack, the generated lift eventually raises the hydrofoil and the rider out of the water, thereby reducing drag. Moreover, this speed doesn't need to be very high to produce sufficient lift, because the lift calculation formula is as follows. It is proportional to fluid density and the square of fluid velocity. Since water is about 800 times denser than air, a hydrofoil in water can generate enough lift at much lower speeds. If the water itself has a current, you might not even need additional power to ride it. Understanding this, let's see how a powerless hydrofoil board works in water without sufficient flow, relying solely on the rider's movements. The key lies in controlling the lift and thrust of the hydrofoil through body movements to maintain a stable forward speed. First, let's look at the key movements and principles of the entire process. 1. Initial push. The rider usually takes a few running steps to generate initial momentum. Once speed is achieved, lift is produced. 2. Jumping onto the board. When the rider jumps onto the board, they first press down hard with their back foot, causing the hydrofoil to dip deeper into the water. This increases the angle of attack of the hydrofoil. The greater the angle, the stronger the lift. 3. Body extension. The rider stretches their back and raises their arms, using body extension to help the hydrofoil generate additional lift. 4. Body contraction. The rider quickly tucks in, pulling up their knees and momentarily reducing their weight on the board. This allows the hydrofoil to rise rapidly without excessive drag from downward pressure. 5. Weight shift. Once the hydrofoil reaches a certain height, the rider shifts their weight forward, pressing down with the front foot. This reduces the angle of attack, decreasing lift and drag, while increasing horizontal thrust, leading to acceleration. The rider then repeats these movements in a cycle, maintaining rhythm to ensure continuous lift and stable glide. Though seeming simple, mastering it is not easy. It's one of the most technique and stamina-dependent hydrofoil disciplines. Tips for learning powerless hydrofoil. Start by practicing balance with a tow rope. Once you reach a certain speed, the board will lift. Alternatively, try an electric hydrofoil board, which is much easier. It uses an electric propeller for propulsion, allowing you to experience the sensation of flying over water with less effort.